So then just simulating that kind of second part of the sequence. Let's just reset our code. So we tested the first part just to show the second part working. Go ahead, press play, and make sure we've got this set up. And then what we can do is press that. So A goes forward, B goes forward, and B should come back. A should come back. Then it should repeat that again. So A forward, B out and back, then A back. We should see C go off then eventually. 1 second delay. 2 of them out, 2 of them back, 2 of them out, 2 of them back. Then again C off. So we stopped at, whereabouts are we stopped? We're stopped at step 200. So I was just booted them out, booted them back, booted them out, booted them back. C off, 1 second delay. And then we should be at 200. Yep. So we're just going to have this last sequence to put in. So there's quite a bit actually to go ahead and code for that. So I'm not going to go through all the steps. It's the same procedure again. But what I do just want to show you is towards the end how we get it back around to 0. So I'm going to go ahead and update the program and put it in, and then touch back in just on the end bit of it. So I've gone ahead and done all the outputs for all these step numbers. Okay. So you can see I've done for the D. Now I'll come back to that and I'll talk about this one in a minute or later on. You can see my A command is quite long. You know, our code for ladder logic now becomes really stretched. But you know, that's all the outputs done. So then it's a case of adding in our next lines to generate our inputs for these. So I'll go ahead and do that now. So again, I've just added in enough blank steps to get me down to, well, I went down to 390. So probably one extra. So now it's just a case of putting in the inputs as they change. So I've put in then all the scenarios, quite a long sequence in itself. So I put all those steps in. So then at 370, we got to check is C off before we go into 380. And then 380 is the last one we've got to check. Does 380, does D go off now? And then we go into our next step. Now this is our last step. So we need this to loop back around. So we want it to loop back around to 0. So we're going to move 0 back in, because then we're going to be, all the way back to here. To where we can press the start button and pen will go in again. Now, just a couple of things to note. We actually, if we wanted to really loop back around to 0, I could put 0 there and just move this here. Sorry, let me just scooch this in a bit better. Maybe put it in this way. That's being funny. So I was just being a bit funny, but there we go. Now it's actually going to go back to this line here. If I didn't have this, anytime I press the start button, it would just go to, it would move to line 10. So it depends really what you're looking for in terms of what your fault find is or where your actual system's working. But if you want to basically have the start button ignored after we press it, well then you'll need this at the start. If you don't, then anytime you press the start button, it will activate this line. Because ladder logic, is not sequential, we'll be able to trigger that line unless that 0 there is before it. Because we have the 0, the 10, and the 20 before it, and we're doing this kind of moving across, that allows us to keep the code sequential. But if I didn't have that, anytime I press start button, I'd be able to move 10, the variable 10, in and essentially disrupt the system. So that's how we can kind of tie it back around. We go to 0 at our last point, we make sure we've got 0 at this point, and then that keeps us nice and rigid. If you wanted buttons, there could be a case where you have emergency stop buttons and other push buttons that you maybe want to be active in parallel to all this code. You may not have this equal to in front of it. Okay, so that should allow us to loop back around. The last bit of the sequence is just basically one cylinder moves in and out twice each time, and then the rest of the lights go off. So what we can do is we can go ahead and load this in and trial it and see are we winning. Okay, and I just need to reset this back to 0, make sure everything's good to go. We're nice and blank here. So we go through our system. I'll need to do a build. Need to make sure my simulator's running. Hang on. Right, so I just forgot to put on one of my settings. So we'll do the usual sequence that we've seen so far. We should see the light go off, 1 second delay. This is the second sequence, both of them in, both of them out, both of them in, both of them out. Light goes off, 1 second delay, and this should just move in and out twice. Then this one here should move in and out twice. And we should see that again. Should move in and out twice. And then this in and out twice. And then both LEDs should be off. System's back to rest, so now if I press start again, it should run through my sequence. And that's essentially the full system. I can still see it trigger nicely through my steps. It shows you how to do the sequential code, how to keep ladder logic sequential. Now you can see this is quite a long, now we've watched 45 lines of code in here, and it's quite long. It can get a little bit messy, so in a couple of my other videos it really starts to point the finger at when you start to need separate functions to tidy up your code a wee bit. So we'll look at that in a separate video. But essentially, it's a really powerful method, this coding method, to keep everything, it can follow a nice platform here. All the work is done here. You can get every bit of information from this, and you can fault find it really easily. You can keep track of your integers of where the code is maybe falling short, or keep track of it quite nicely. I've shown you some of the good simulation tools in here, but you can see some of it gets a little bit long and interwinded. But if it did get stuck at say a line 130, you'd just come up and you'd really look at maybe each line before or after it, and you could kind of pinpoint to where your problem is. It's going to be in those 3 lines, or indeed with the output that's not working. If it was output C, the LED C that wasn't triggering, it'd just be in here. So it does shorten it down, but as these sequences do get long, it could look for a need of maybe using text-based coding, or maybe even just doing some functions and stuff just to tidy it up. But a really powerful method, really easy to use. It's a very complicated system that we've looked at here, and just for beginners anyway. And we looked at some good simulation tools with it, and kind of a good approach to solving this type of problem.